Hello students, today we are going to learn about measurement. So this is a part of mechanical measurement and system. So first we will start with measurement. So before going to that, let's remind how many times you have encountered measurement. So from since childhood, remember if since childhood, uh, when we have been introduced to geometry, we must have seen that the we learned how to use scale, we learned how to use protector. So in that one we were given tasks to draw like 1 centimeter line or 5 centimeter line, 90-degree angle, 60-degree angle. So those time we were using a scale and we were drawing the lines. Okay. Similarly, if you remember, when you entered engineering, you must have learned about engineering drawing. In that one, we must have learned about all the type of measurement systems. We have used the scales, we have used the ruler, we have been using the drafter, the pro circle, set squares, everything. Those all things we have been using for measurement. That is all I can say academic related. But if we don't think about academic related also, if we go for our day-to-day life, in that case also we are observing that we are using measurement in many of the cases. Mostly being engineering student, the people are using bikes for communicating from one place to another place. In that one, we are using speedometer. That is also a measurement device. Similarly, when we go to shop to buy something, we are weighing the thing and bringing that one back to home. That is also one kind of measurement we are doing. We are going to gym and doing workouts, or we are going for work. We are counting our footsteps. We are counting how many kilometers we have traveled. Those all things are how much calorie we have burned, how much calorie of fat we have burned from our body. All these are called as measurement. Now, okay, I can say these are all examples of measurement, but how can we define a measurement? So, measurement is nothing but a process of comparison. I can say it is a process of comparison. Comparison we are doing with whom we will do, of whose comparison we are doing. So let us consider we are having a physical quantity. For example, let us consider I am weighing my weight. So weight will be here is the measurand or the physical quantity. We can say this is the physical quantity. This might be a weight, this might be any of the thing. Those are specifically they have one name that is called measurand. Okay. The quantity which we are supposed to measure is called measurand. Measurand, we are going to compare the measurand with whom? With the standard. To understand this one, as I told you, we are having weight, then we are having standard weights. We are going to compare that one. For example, let us consider I have a straight line over here. I am going to use a scale to measure that one. So this length of this line is our measurand. The scale will be our standard, and we are going to compare this line with the standard and give a number to this one. For example, let us consider this is 5 centimeter. We are quantifying that one, the number we are giving over here. Measurement, like we can say, you can say like something is there big and small, bigger and smaller. Those are also type of comparison, but we cannot say they are measurement. They are called as your measure. They are called as a comparisons only. But when we are talking about measurement at that time, we are supposed to give a number to a particular measurand. Whichever thing we are measuring over there, for that one quantified number will be given. For example, we are taking our IQ. IQ is something which is not physically exist in front of us. It is something our brain's capability to analyze the thing. But when we are giving the number to that one, we are calling that one as measurement. If you are saying someone is smart, then that is not measurement. That is one type of comparison. Like person A is there, person B is there. You are saying person A is smarter than person B, then that is comparison. But if you see the number A person is having 100 IQ and number B person is having 90 IQ, that means you are measuring the intelligence in over there. That is called as the measurement. So when we are talking about measurement, first we will see what are the different types of measurement systems we are having. You can see over here, I have represented one system which is representing. So I say this one is measurement. For example, let us consider I am talking about length. This length we are going to measure, compare with either scale, ruler, or we can say we are comparing it with the measuring tape. Okay, those all are called as your standard. We are comparing this length with these standards to get a readout number, quantified number, say 5 centimeter. Okay, this is called as your measurement. This is measurement. Now, when we are talking about types of measurement, we are having different types of measurement. What are those different types of measurement? We depending on we are having two criterias. We are having two criteria. Depending on that, we are defining or differentiating the measurement. First type is the based on the requirement or standard. Okay, so we can say if we can say let us consider based on requirement or standard. Okay, so here we can say one will be your direct measurement or it may be a indirect measurement. Okay. So when I am talking about direct measurement, in this one, we are going to use the instrument and directly we are going to get the value. So here we can say that the value of the physical parameter will be determined by comparing directly with the reference standard. So in this case, example we can take is scale itself, which is a very common thing we are using in our day-to-day life, that is scale. So as I told you, if we are having this line, to measure this line, for example, we are using the scale. Directly we are putting the scale over here and assigning a number, that is direct measurement. But when it comes to the indirect measurement, the physical parameter more generally measured by the indirect comparison with the secondary standards. Okay, so what we are doing over here, here this indirect measurement may also be related to your secondary and tertiary measurement. Here, there we need a conversion. For example, let us consider. So about this one, I will tell you about secondary or tertiary measurement. So we'll go to the name. When how we did we got the secondary and tertiary measurement. So we can say that based on the complexity of the instrument, complexity of the instrument, we will be getting three different types of measurement system. First one will be primary, second one will be secondary, and third one will be tertiary. So what we got in case of direct measurement, that is only called as your primary measurement. So in direct measurement, what we did, we used the instrument to measure the measurand. Directly we are using the scale and we or directly we are using the instrument and getting the data. That is our direct measurement. And there is no relate conversion is needed over there, either in the instrument or in the calculation. That's why that is called as your primary measurement. And that is also direct measurement. Similarly, in case of secondary and tertiary measurement, there will be a so what we will find here in this case, there will be no translation we find in this case, but here we are finding the translation. Okay, so here in both this case, we will find a translation. So what translation I am talking about here? For example, let us consider we are going to use a spring balance. Okay, there is a spring balance we are having over here. Okay, these are the graduations on the dial we are having. You must have seen these Anganwadi persons are weighing the weight of the small kids. So what they do, they are using a spring balance. There will be one sitting position or sitting or there will be hanging portion will be there where they can make the kid sit in there or baby sit in there. So when they are putting the baby in the seat, it goes down. So the spring goes down. Because of the movement of this spring, what happens? This pointer starts to move over here. But the pointer movement is because of the movement of the spring, the pointer is moving. As this weight makes, or this is our measurand, this measurand makes this spring to move. This spring makes this pointer move. So this one translation, this is second translation. So that's why there is translation occur here. But this is not secondary translation. In secondary translation or secondary measurement, only one translation will be available. Just like if we are using a spring to measure the deflection, that will be a secondary secondary measurement. But if there is more than one translation is there, it will become tertiary translation. To understand this one, let us consider a Borden tube pressure gauge. So in case of Borden tube pressure gauge, what we are having is a Borden tube, which is basically a capillary of C shape. Okay, you must have seen those pipes we are using on the birthday celebrations. In that one, when you blow the air into inside the pipe makes noise. Along with that, there will be a pipe or there will be a ribbon like thing that is going to extend for some distance, will become straight, and when you release the air, it will become roll again. Okay, the same concept also working here. So this is one type of capillary. When your pressure is going to act on the fluid of the Borden tube pressure gauge, that fluid makes this Borden tube straight. So initially it will be C shape. For example, let us consider After applying pressure, this is the deflection we are getting. Okay, because of this deflection, what happened? There will be uh, one pointer will be there, one link will be there, which is attached to the pointer. So when it moves, it also makes this pointer move. There will be translation by using gear drive there. So first force is included over here. Force is applied over here. Because of that, this first translation we see. Because of this one is moving. Second translation. Because of this one, this pointer is moving. Third translation. So this is a tertiary measurement. Okay, so these are the types of measurement we are having and we are using in our life. Another type of measurements are there. Another type of measurements are there. They are contact type and non-contact type. Okay, so in this case, we can say contact type means the measure hand is in contact with the measuring system. That is called as your contact type. Examples may be taken as our pressure positive pressure gauge, or we can say we are considering our scale. These all things are contact type. Non-contact type means the physical quantity will be in a remote area. Remote doesn't mean that it will be very large distance. It may be in a larger distance, it may be with a shorter distance also, but there will be no contact between the measuring system and the measurand. That will be called as your non-contact type measurement system. Just like we can say contact type measuring system is our normal mercury thermometer. Okay, contact type. In this case, we can say the thermometer have to be in contact with the person for which we are measuring the fever, and the body heat is going to rise the mercury so that it will give us the temperature. But in case of your laser thermometer, what we are having, we have been using in our COVID time, you must have seen it. We are having a light which is incidented on the human body and it is sensing the temperature. That is a non-contact type measuring system, we can say. Next comes is your generalized measurement system. And this is the block diagram you can see over here for the generalized measurement system. You can see this is the physical quantity we are supposed to measure. For this physical quantity we are measurement, we are having many of the components you can see over here. Okay, so you can see that this physical quantity first comes in contact with the sensor. A sensor is this one, is that instrument which is going to sense the external stimuli and act according to the predefined way which is already defined to it. That means, for example, you can consider the sensor which is used for the pipes, tapes. Okay, for the tapes. So if when you are putting your hand under the tape, the sensor sense the body heat and release the water valve so that water come out of the tape. That is, that sensor is sensing the body heat. But how does it act? It act according to the definer or the manufacturer. The manufacturer is going to define it that when you sense the body temperature or temperature more than this, then you have to release the valve. That is a predefined way. So that is a sensor. So the sensor here is going to sense the stimuli or the physical quantity, then release the data to the transducer. It will be giving the data to the transducer. What transducer will do? Transducer will convert the from signal form of one physical form into another without changing the information. So what it will do, whatever the data sensor will give to the transducer, it is going to transmit it to the manipulator. But there will be no change. Only a translation will be there. As I told you, pressure is given to the current pressure gauge. Then that is transferring to that motion to the pointer. It is a translation, it is a type of translation. So when you give a displacement to the particular element, the transducer is going to change the displacement value or the distance, a change of position in a form of EMF to the output, but it will not change the data over there. It will be keeping the data same only, but it may be in a other format. Okay, that is the manipulator, that is the transducer. Then the transducer is giving data to the manipulator. What manipulator will do over here? Manipulator will do, it will use some mathematical calculations or mathematical formulas to convert the signal into a processable data. So basically we can say manipulator is not does only multiplications here. Okay, multiplications means what we can say. For example, let us consider we are doing a unit conversion. So in that one, there is a particular x value. With that one, we are multiplying a constant. So by doing this, we are changing only the form of the data, but not the exact value. Okay, so this is what the work of a manipulator. Then it will go to transmitter. The work of transmitter is to transmit the data as it is from the manipulator to the manipulator to the processor. It is just like a carrier, you can say. Okay, so now processor will, what the processor will do? Processor will do if any kind of uh, like changes or modifications needed, then it will perform that one. Okay, it may be do the some correction, it may do some change of format, it may do some kind of your unit conversion. Okay, or it may add some offset value. All those things that processor will do, that is what is the important thing. Okay, processor, from the processor the data will go to indicator, controller and recorder. So in this system, what you see, the mandatory things are input stage, intermediate stage, and the output stage. This is the output stage. Okay. Now in input, there may be a sensor, there may not be a sensor, there may be a transducer, there may not be a transducer, but either one of this one should be there. Similarly, in the system, manipulator is a compulsory thing. There may be a transmitter or processor present or not. These are the optional things. Similarly, indicator will be a compulsory thing, but controller and recorder may present, may not present. Then question comes, what is the work of indicator, what is the work of controller, and what is the work of recorder? The name itself, it is saying indicator, means it is going to indicate the data. For example, in case of a dial gauge, the dial gauge and the pointer are the indicator. In case of a digital uh, pressure gauge, or we can say digital uh, impact testing machine, in that one, you are getting the number in a display unit. That is your digital indicator. Okay. Similarly, recorder. Recorder is like something you are attached with computer. It is going to save the data, repeated calculations what you are doing or repeated measurement what you are doing. It is going to keep that data safe. That is called as your recorder. Or if you consider in your labs when you are performing the test, the recorder are you observers. Okay, that is what is your recorder. Similarly, what is a controller? Controller is that one. Like for example, let us consider we are having a pressure vessel. In that one, maximum pressure it can bear is 100 megapascal. Okay. Now, if the pressure increases from 100 megapascal, the pressure vessel is going to burst. That's why there will be a controller when it reaches to 99 megapascal. At that time, that controller will release the valve so that pressure will drop to the safe value again. That is what is the work of a controller. This is a sort of example like if we are using controller in many of the cases in our industries. Okay, so this is what is all about your general measurement system. So this is all for today's class. Next class we are going to learn about different type of measuring. We are going to learn about different type of characteristics of measurement what we are having. Okay, so see you in the next class. Bye.